2 in our notes. Today's topic is parallelograms. If you flip backwards in your notes a little bit to the very first page, we have this flow chart. Every shape that we're talking about from here on out is a quadrilateral. That's just any shape that has 4 sides. Today we're going to start the first branch of quadrilaterals, which is parallelogram. You can see the things that branch off from being a parallelogram are some of those recognizable shapes like rectangle, square, rhombus. Today we're just going to talk about parallelograms. Okay? So, the first property of parallelograms, and I would box this whole thing in, highlight it, whatever you do, mark your page to save it. The first property of parallelograms is its most basic definition. If I ask you what a parallelogram is, or to prove that something is a parallelogram, this is the one that I am looking for. By definition, a parallelogram is a quadrilateral where both pairs of opposite sides are parallel. Okay, that's the most basic definition. I'm going to mark up my diagram with all these different properties. So my first property, both pairs of opposite sides are parallel. I'm going to draw in those little parallel arrows to show that opposite sides across from each other are parallel. Easy enough, right? That's our definition. From there, we get a bunch of extra properties that tell us about sides, about angles, all that good stuff. The first one is that both pairs of opposite sides are congruent. So not only are they parallel, but we also know that they are congruent. They can get those congruent tick marks. The next one is that both pairs of opposite angles are congruent. When I talk about opposite angles, I'm talking about across from each other in my shape. So if I talk about this angle, its opposite angle is all the way across my parallelogram to here. Those two are, those two are opposites. And same thing here, all the way across to here. Those two are opposites, and opposite angles are congruent. So we could set these two angles equal to each other. We could set these two angles equal to each other. Questions about those ones? Okay, next one is a little bit weirder. It says consecutive angles are supplementary. What does the word consecutive mean? Does anybody know? It means one after another, right next to each other. So consecutive angles are any two angles that are next to each other. They touch each other. So these two angles have to be supplementary, which means they add up to 180 degrees. I could say the same thing about these two angles right here. I could even go the other way and I could say these two angles or these two angles have to equal 180. As long as they are two angles that are right next to each other, aka consecutive, they add to 180. Now we're going to talk about diagonals. We're going to see diagonals drawn in all of the shapes that we talk about this unit. They all have different properties. A diagonal is formed when we connect opposite corner to opposite corner. So if I take these two corners and connect them, take those two corners and connect them, I have two diagonals drawn here now. For parallelograms, the property that we get with those diagonals is that they bisect each other. What does that word bisect mean? It means they cut each other in half. So, this does not tell me that these two pieces are congruent. It does not tell me that all 4 of these little pieces are congruent. All it tells me is that each line is cut exactly in half. So these two halves are congruent, and these two halves are congruent. Questions on that? Now, the last one here is kind of a weird one because it's well, duh, we already said that. This one we use to prove parallelograms a lot. Not an actual proof, but it's just here's a shape. Can you tell me that this is a parallelogram, yes or no? This is the one that we use for that quite often. It says I have exactly one pair of opposite sides parallel and congruent. So if you have a pair of sides that is both parallel to each other and congruent to each other, we have enough information to say that that's a parallelogram. Kind of a weird one. Any questions about these properties? This is a big unit on memorizing properties, so you want to make sure that this is marked, highlighted, starred, whatever you need to do. You need to remember these 6 parallelogram properties, especially the definition of parallelogram. Good? For some examples, we're going to reference these properties, so make sure you have them available while we go through these. In the first example, I am solving for whatever angle measures I have here. I have x, y, and z. Can anybody tell me how we get any one of these angles? There's a pretty easy one right out front that we can see. If anybody wants to give it a go. Caitlin? I think it's 105, but yes. Z is 105. The property that says that z is 105 is that opposite angles are congruent. So that means z and 105 are opposites. They are congruent. Whenever we write angle measures, by the way, just make sure that you put a little degree symbol next to it. Okay, that's 1. Anything else we can get? Anybody want to give this one a go? X or Y? Go ahead, Aubrey. How do you know? They're alternate interior angles. So let's say those 2 lines are my parallel lines. We know that the opposite sides are parallel. Then we get a transversal. And not only do we get that X and 31 are alternate interior angles, but we also get that 44 and Y are alternate interior angles. So we could say that because opposite sides are parallel, then we get alternate interior angles congruent. This is not a proof reason that you need to know. I'm just justifying it so that you could mark it down in your notes. This is why we could do this. This is why we could do this. Good on this? Okay. Flip it over. Number 2. What are we going to do here? I need a setup. Gabby? They are parallel, but that doesn't tell me anything about the side lengths. Casper? Opposite sides are congruent. So I want to say that these 2 sides are congruent. 5x plus y equals 18. And I can say that these 2 sides are congruent. 2x minus y equals 24. So now I have 2 pieces because opposite sides are congruent. And then from here, how do we solve this? Substitution, elimination. Nobody's going to graph. I'm going to do something I rarely do, and I'm actually going to eliminate this just because it's so easy to eliminate. It's almost begging me to eliminate it. I have a y and a negative y. Those cancel each other out. 5x and 2x gives me 7x. 18 and 24 gives me 42. If you do not know what I just did, go ahead and substitute. It's okay. So x equals 6. And then to plug it back in and find y, is y 24? No. Y is negative 12, right? Right? Yes. Questions on that? Lots of properties here, lots of properties. Look at number 3. What property am I looking at in number 3? Gabby? Exactly, the diagonals bisect each other. That does not mean that this whole thing from x to z is equal to this whole thing from w to y, but it does mean that the 2 halves are going to be congruent to one another. So what that looks like is a and b plus 2 are congruent. And it looks like b plus 10 and 2a minus 8 are also congruent. Again, I'm looking at a system of equations. This time I'm going to choose to substitute. Because I have that a equals b plus 2, I can plug that in very easily. I'm skipping steps, sorry. But then I get 14 equals b. And from there, it's just a matter of plugging back in to get that a equals 14 plus 2, or 16. Specifically with these two problems, if you are not feeling confident about solving systems of equations, that is absolutely something you are going to need a lot this unit. So please make sure that you are reviewing how to do systems of equations. Let me know if you still need help with that. Okay, a couple more. Number 4. What do we think about number 4? Properties, what do we got? There's one that's probably the easiest because we just did one like this. What about those C's? How can I set up to find C? Dahlia? Yeah, opposite sides are congruent for C. So I can literally set up 3C minus 3 equals C plus 1, or 2C equals 4, C equals 2. Beautiful. Now I need to find A. What do I know about those two angles at A? Anna? Perfect. These two angles together equal 180. It is very common mistake for people to say, oh, those two must be congruent. They are not. They are consecutive. Consecutive angles are supplementary. So I would say A plus 40 plus A equals 180. Maybe I make myself a little angry face note over here. Do not say that A plus 40 equals A. That's bad. We don't want that. From here we solve. A is 70. Questions? One more kind of like this, and then I'll show you something a little different. Okay, this one's kind of a hard one. What do we have here? Aubrey? Right, and why do you know that? What are those angles? Exactly. I have two pairs of opposite sides that are parallel, so I can use both of those to draw my transversals. Let's start with the 2x and the 24. If I use these as my sides that are parallel and this is my transversal, I get alternate interior angles here. So 2x equals 24, x equals 12. And then using that same logic, if I choose these as my parallel sides, and that's still my transversal, then I should also be able to get that x plus y equals 20 by alternate interior angles. How do I find y now? I'm going to take what I found for x. I'm going to plug it in. 12 plus y equals 20. Y equals 8. Any questions on that? Okay. We are going to spend a whole day on problems like number 6, but I'm going to introduce them to you right now. This says, prove the figure is a parallelogram using the definition. Let's start by plotting those points. I have A here, B, C, and D. Everybody with me? Everybody got their shape? I want to prove that this is a parallelogram, and to do that, I need its definition. What's my definition of parallelogram? Anna? Perfect. How am I going to prove that these opposite sides are parallel? What do I need to know for them to be parallel? Dahlia. The slope has to be, the slopes have to be the same. If we want parallel lines, we have to figure out that these are the same slopes. All I'm going to do here is I'm going to figure out, here are my two opposite sides, so AB and CD. I want to make sure that those two opposite sides are parallel, and then I'm going to do it again for BC and for AD, and make sure that those two opposite sides are parallel. I'm literally counting here. We remember we count slope from left to right. I'm going to count rise over run, and then rise over run. Are those two sides parallel? Same thing for BC and for AD. Rise over run, and rise over run. Are those two sides parallel? So because we have both pairs of opposite sides parallel, we can say yes, and then maybe a justification. Oops. Questions?